afternoon, everybody. Welcome to our session. This is Intro to AWS IoT Twin Maker. It's a new service that was announced yesterday in Adam's keynote. So if you watch the keynote and you're curious about what Twin Maker is, or you're thinking about applying digital twins to your operations, or you're already building digital twins and want to learn how this service can help you get there faster, then this is the session for you. My name is Saras. I am a Principal Product Manager in AWS IoT. And with me today is Dane Laughlin from Invista, who's here to talk to us about how industry leaders such as themselves are applying digital twins today. We're really excited to share with you what we've learned in this space over this experience and hopefully inspire you to think about how you can apply digital twins in your businesses. Thank you for being here, and with that, let's get started. On the agenda today, we'll cover a brief background on what digital twins are and how they're used. We'll talk about how digital twins are built and what makes it so challenging. We'll take a deeper look into Twin Maker's capabilities, and then I'll hand it off to Dane to talk to us about their motivation and experience building a connected worker tool using this new service. Okay, so what are digital twins? There's a lot of interpretations out there, but simply put, digital twins are virtual representations of physical objects and processes that very closely mimic the state and behavior of the physical counterpart and are built to solve specific business challenges. Customers are using digital twins to get better visibility into their operations, to get a deeper understanding about their environments and looking for ways to improve and bring improvements into the environment, and even using analytics on the digital twin to generate insights that are then applied to the physical world to drive those improvements. But digital twins are not really a new concept. They've been around for a long time, but what makes them relevant now is customers across industries are focusing so much on digital transformation, as well as advanced technologies like graph databases, immersive visualizations, broad adoption of IoT, machine learning, and cloud computing in general has made digital twins not just possible, but within reach for all our customers. Going back to the solving of specific business challenges, nobody wants to create digital twins for the sake of creating digital twins. It's really hard. The first question we have to ask is, what is the outcome that you are working towards? That's the only way to define the problem and then solve that problem. So if you take the business outcome as a given, now you can start to think about what data or input needs to go into it. You can start to think about what insights you want to generate from that data, as well as what's an intermediate business outcome that gets you part of the way there. When you answer these questions, it gives you a better understanding of what your digital twin needs to look like. How are you going to use it, and what improvements it's going to drive? So we spoke to a lot of customers across industries, and they shared with us a lot of interesting and innovative use cases. What we found was that a majority of customers are focused on applying digital twins to transform their operations. I'll give you two examples. When an operator is trying to root cause and correct operational issues in manufacturing, they're slowed down by having to constantly context switch between different applications that have the data that they need to solve the problem. They're pulling up asset information with a specific asset ID. Then they're trying to pull up quality or maintenance history data with probably an asset ID that does not map to the other applications. They're switching between all these different dashboards. And this kind of context switching and different applications slows down resolution of the issue and can lead to, equipment failures or downtime. But what they really need is the ability to visualize the data that they need to get the job done in the context of the environment that they actually have to apply this to. And they want to do this using a comprehensive application that is essentially a single pane of glass, giving them real-time 3D view into the facility so they can quickly pinpoint and address those equipment and process anomalies and reduce the time to resolution. It also enables remote experts to be able to have a comprehensive understanding of their operations, making it more effective for them to do their jobs. As another example, customers in real estate are hyper-focused on improving occupant health, safety, and comfort. And the way they want to do that is by collecting data about temperature, occupancy data, energy consumption data, air quality data, and visualize that in the context of that environment to see what are areas of improvements that they can focus on. Also allows them to visualize how energy is being consumed in the building at a granular level, so at like a floor level or an individual room level, to see like what are some optimizations that they can apply to start to think about reducing their carbon footprint. But these are just two examples of a vast array of use cases that digital twins can be applied to. And we find a lot of customers want to start here. They want to connect data sources from all these different sources, bring it all together, visualize it, and then start to understand like what are improvements I can make, what are areas that are ripe for innovation and will drive improvements in their businesses. So let's talk a little bit about how do you make these digital twins. So customers and companies are collecting and generating so much data, not just data in volume, but different types of data. You see here, there is IoT and process data that's being collected from IoT sensors and devices and equipment that tell you the current state of these machines. There is visual data, the as-designed context from CAD files, or as-built context from point cloud scans. There's geospatial data, there's modeling data, as well as video data from cameras that are deployed in these facilities. These are all very different kinds of data. But when you're thinking about building digital twins, you have to bring all of these pieces together. Depending on your use case, you might need all of them or a subset of them, but you do have to bring them together and codify them into a virtual model that represents the physical environment where these data sources are relevant, how they're related to each other, and what are the various elements in that environment. And you want to use that to drive insights. And once you have that digital twin, you want to embed those into end user applications. These are the applications that end users use to consume the data and insights from your digital twin and use that to do their day-to-day jobs and find those areas of improvement to improve operations. What we find, though, is that there's a layer of shared data and resources that is generated that truly forms the foundation of your digital twins. And if you think about a typical asset going through its life cycle from design, build, operate, there is different types of data and resources being generated and collected. For example, in design, you're getting your CAD files, your bill of material. In your build, you have other vendor information. When you get to operations, you have maintenance, IoT data. All of this data truly forms the foundation of what needs to go into that digital twin. And that's why we believe AWS is the best place for you to be building your digital twins, because of the breadth of solution that we have available, from edge solutions for data collection and ingestion, purpose-built databases to store different kinds of data, advanced analytics, serverless compute resources available to you. So essentially, we want to bring the power of AWS's entire portfolio of services to bear on your digital twin use cases. And for that, data is a key enabler. When we talk to customers, they tell us digital twins are really hard to build, and we believe them. Building and managing digital twins, it's complex, it's time-consuming, it's complicated, it's costly, and it requires specialized skills from developers that not all customers have. The three main key pain points that customers point to us is, I have so many different data sources. These data sources hold important context for my digital twins, but there is no seemingly easy way to connect the dots between them. The second challenge they describe to us is modeling physical systems is very complex, because physical systems are complex in nature. And being able to do that, that tracks the asset's lifetime gets even harder, because you have to now think about version control. And third, digital twins are used by the end users, and you have to make these visualizations effective for the end user, and it has to be applicable for the use case and for the persona that's using the digital twin, and in a way that makes their job easier. So should not have information overload, but also should not be context switching. So it needs to be very specific to the challenge that customers are trying to solve. So that is why we're very excited to announce in preview AWS IoT TwinMaker. These challenges that customers have told us over and over again was the motivation for us to build this service. So we're really excited that we're now able to make this available to all our customers. What is this service? It's a new AWS IoT service that allows you to make digital twins of real-world systems faster and easier than ever before, and use them to optimize your operations. The three key benefits of the service: one, it lets you access data where it lives from various different sources without having to re-ingest the data, without having to move it all into a single repository. So truly, the data can live where it is. Second, it allows you to accurately model your complex physical environments into a knowledge graph that understands all the different elements in that environment, the data sources behind those elements that are relevant, what are the relationships between them, what are the interactions that they have, so you can start to create a virtual digital version of that physical environment. And then third, creating immersive 3D views. A lot of the customers that we spoke to are really focused on bringing those 3D next-gen experiences to their end users, because it's been proven that visualizing data in its natural context makes it easy for operators to understand and comprehend that the data and insights that they are trying to use to get their jobs done. So those are the three key benefits of this service. This is a very visual concept, so I want to play a quick video so we can get on the same page of what kinds of applications I'm talking about. So this is a cookie factory demo that we've built. What you're seeing here is you can easily bring together data, sensor data, equipment data, video feeds from cameras, and other context into a consolidated digital version of your operations. You can create immersive 3D visualizations of your environments, showing real-time data, video, and all the context that's been modeled to help your operators make better decisions and make them quickly. So how does it work? How did we make that? There are 4 key pillars, and I'll talk about all 4 of them in the next few slides. It's data connectors, model builder, scene composer, and application toolkit. We'll start with data connectors. So data connectors from TwinMaker allow you to connect to disparate data sources wherever they may live. Our motivation behind data connectors is to truly embrace the brownfields and create a federated interface that acts as an abstraction over the underlying data sources. It fuses data from IoT sensors, cameras, documents, maintenance history, other context sitting in business applications, and it's able to fuse context between all these different data sources. And how it does that, it creates a knowledge graph using these data sources. The data connectors come built in with AWS services. For example, we have out-of-the-box connectors for AWS IoT Sitewise, a service that stores industrial IoT data. It connects seamlessly with Kinesis video streams that allows you to ingest and store video data from cameras, as well as allows for live and historical playback. And while I'm on the topic of KVS, Kinesis video streams, we also just announced a Greengrass Edge connector for KVS that now allows you to control what video from cameras is uploaded to the cloud for cases where you have bandwidth constraints or you want to limit the amount of video that you're storing in the cloud. So it enables you to upload data based on certain triggers. The trigger can be a user requested a video segment. It can be an alert has happened in the facility, and because then you can use that as a trigger to only upload certain segments that relate to the timestamp of the event. So a really cool tool to add video to your digital twins, but do that in a cost-effective manner. And we also have connectors to Amazon S3, which we know is a typical place where customers are storing application data as well as unstructured data. But it doesn't end there. We know that there is so many data sources out there that customers want to connect to. And as we go forward, we're going to add support for more data sources. But we wanted to make it easy for developers to get started creating connectors for their own data sources. So we added a flexible framework that allows you to write your own data connectors to data sources that you may be using. We have samples available for data sources such as Amazon TimeStream, Siemens MindSphere, as well as Snowflake. And you can easily take these connectors using our custom connector framework and apply them to any of the data sources that you want to connect to your digital twins. Next, we'll talk about the model builder. This is how you describe relationships and data properties for your digital twin. Our model builder embraces the entity component architecture. Entity component architecture is commonly used in game development, but as we talked to customers and they described all these use cases to us, we realized that this is a very good fit for modeling digital twins as well. Simplistically, what this architecture allows us to do is model elements in your environment as entities. This can be equipment, it can be processes, people, spaces, and you attach various components to that entity, and that component brings context into that entity. So based on the state that each of those components is in, it drives the behavior for the entity that they are attached to. So all the data connectors that I talked about in my previous slide are now essentially components that you attach to entities, and these entities can be pieces of equipment, it can be assembly lines, it can be processes that you want to model into your digital twin. So it's a really flexible way to build out your digital twin model into a knowledge graph. And this knowledge graph is essentially common metadata that connects the dot between all these different pieces. What this common metadata or knowledge graph allows us to do is provide a single unified API on top of our knowledge graph that essentially removes the heavy lifting from the application development side to how you query for data coming from your digital twin. So all you have to do is call TwinMaker APIs and ask for, I want data for this entity from this time to this time, and the complexity of knowing where this data lives, what data store it is stored in, and how to query that particular data store is abstracted away. So it's a really powerful tool for rapid application development using these simple APIs. Another thing that the common metadata allows us to do is put all these data streams on a common timeline. That means you truly have the power to like rewind time and see the state of your environment or your facility at that particular point in time. And rewinding back in time doesn't just do that on a data stream per data stream basis. It essentially rewinds time across all your data so you can truly see the state of your environment in the past. And at the heart of a lot of the stuff that we have done with TwinMaker is to make managing change easy, because we know physical spaces and physical environments change all the time. So with this model builder, as your operations mature and you start to collect different types of data or new data streams, what that looks like is you're adding additional components to those same entities without having to redo the graph. So it's really easy to keep your knowledge graphs up to date, and as things progress, bring those improvements into the virtual digital twin as well. Get a sip of water. Okay. Next, we have the Scene Composer. Scene Composer allows you to create those 3D spatial representations of your environments with widgets for data. We've embraced importing existing models into the Scene Composer to create your visualization. So we wanted customers to be able to reuse their investments in CAD or 3D modeling that they have already invested. So you can bring in existing CAD models or point cloud scans or other scanning models converted into the GLTF format. The reason we're embracing GLTF format is, one, it's lightweight, it's open source, there is no licensing, so it's just very easy for you to get started using it, and it's also an Exchange format that has been optimized for the web. So it's really easy for you to bring your existing models of different formats, convert them to GLTF optimized for the web, and start building your 3D scenes. What we have in the Scene Composer, it's a very simple 3D composition tool. So it doesn't have all the bells and whistles of a 3D editor. Its purpose is not to create 3D models from scratch. It is a composition tool that allows you to place and position different types of equipment into the same scene, so you can compose an environment that mimics the physical world. And once you have that base scene created, you can add data overlays on top of that. Data overlays are widgets that you add on top of your scenes that connect back to the data that you've modeled in your knowledge graph. So you can add tags that connect back to time series data, and you can define simple rules that tell you how the visual for those annotations need to change as your data changes. So for example, if a temperature exceeds 50 is a rule that you've configured, you can easily see that it changes in real time to depict that this particular equipment that this tag has been added to needs some attention. And again, we've made it easy to manage change, and that is possible because of the composition nature of these scenes. So if you think about, a piece of equipment needs to move from one room to the other, you don't have to create a monolithic model from scratch. All you have to do is select that piece of equipment and move it, and you have a newer version of your scene, and you can move forward from there. And then finally, I'll talk about the application toolkit. So this is how we want developers to be able to create end-user applications really fast. We launched a application plugin for Grafana. This works in both open source, self-managed Grafana, as well as Amazon-managed Grafana if you want to, not have the heavy lifting of managing and spinning up your own instances. And it's based on a front-end developer SDK that we want to make available for our customers and partners to extend these digital twins into their own custom applications, or for our partners into their solutions as well. So we want it to be really flexible and open source in that case. And we're also embracing open source a lot because there is so much innovation happening in the digital twin space. So we want to make sure that there is a place where we are constantly adding samples and tutorials and instructions of how you can create digital twin applications that are specific to your use case. So we have a GitHub repo that stores all of the sample code and tutorials that we have available today, and we'll be constantly adding more over there, as well as integrating with AWS partner tools and solutions available there as well. I want to do a quick plug for Amazon Managed Grafana. It was launched in general availability earlier this year. It's a really cool tool. Grafana is a really cool tool because it gives you the flexibility of data visualization across many different sources. And with Amazon Managed Grafana, you are focusing, you're free to just focus on building those applications without having to worry about maintaining and creating and spinning up and spinning down those instances. Here's another screenshot of the Cookie Factory example built up in Grafana. So if all of this is sounding interesting to you and you want to get started, it is a fully managed service. So you can log into the AWS Management Console, navigate to the TwinMaker console, and you can get started instantly. We also have the GitHub repo that I talked about, has a fully built out Cookie Factory, the one you saw, available there as a sample. So you can download that and get started with your own Cookie Factory in your own account. So you can use that to explore the various features of the service, but the team's done an excellent job to make it like opinionated but extensible. So you can easily replace the data sets in there in the Cookie Factory with your own data sets to create your digital twins. And the GitHub repo, as I mentioned, has tons more samples available. It has samples if you want to connect machine learning inferences from SageMaker for your data streams that have been modeled in TwinMaker. The sample manages the transport of the raw data to the inference endpoint and then transport the inference result back into your data stores, bringing that intelligence into your digital twin. Same thing with if you want to run simulation-based insights from our partner tools. Also, samples are available there, and you can run these ML models and simulation models in real time, so using streaming applications. And those are all available for you to try out and contribute. If you're making something really interesting, bring it back into the community, and we can all share all the good work we're doing here. And I want to call out our partners. We understand there is so much innovation happening in the digital twin space. Our partners are doing an excellent job at the bleeding edge, bringing all this innovation to our customers. So we're really excited about our launch partners. You can see them over here. We have a kiosk available at the Venetian Sands Expo. It's 1957. So if you want to talk to our partners, you want to see how oops, that went faster than it needed to. So yeah, if you want to see these partner integrations in action, please come stop by our booth. Myself and my team are going to be at the booth 1957 again tomorrow morning at 10. So if you're around, please come say hi and look at all the demonstrations that our partners have created. I want to call out, there is so much diversity in the solutions that our partners are bringing to the table. I don't know why this keeps happening, sorry. Yes, we're very excited about our partnership with Siemens to bring their comprehensive digital twin portfolio along with TwinMaker, partners like Embassy of Things and Element Analytics, bringing together the IT and OT world for your digital twins. Consulting partners that are ready and trained to work with you on your specific use cases and customize digital twin solutions. They have the domain expertise and can provide accelerated deployments. As a teaser, I want to show you a quick video of the work we're doing with Siemens. This is a cold brew coffee plant, and we're really excited about this because with this partnership, you can take the capabilities that I talked about with TwinMaker and marry that with the expertise that Siemens has across these portfolio of digital twin capabilities and bring them together into a single pane of glass. What you're seeing here is a Mendix application. Mendix is a tool that allows you to rapidly build applications, and it shows the capabilities from TwinMaker, which is the scene viewer, all the data that's connected to the knowledge graph. In this case, the data is coming from MindSphere, as well as interactions that enable you to immediately switch to detailed context about these assets or this coffee brew line, coming from tools such as SimCenter or coming from PLM tools such as Teamcenter. So you are able to really bridge the gap between going from a facility view into a deep understanding of the piece of equipment that you are trying to diagnose an issue with or whatever the use case is. So we're really excited about this. If you want to learn more, again, please come visit the kiosk. It's 1957. And with that, I will hand it off to Dane. Welcome, Dane.
Thank you, Saras. Can you guys hear me? Awesome. Cool, so my name is Dane Laughlin. I'm an innovation engineer with Envista. Envista is a polymer and intermediates company, and we make a lot of the materials that end up in products that we use on a daily basis and have come to know and love. So instead of boring you guys with a bunch of talk about chemical processes and all that fun stuff, I'm going to play a fun marketing video for you. It'll overview Envista, and then we can talk about how we intend to use digital twins. Oh, cool.
At Envista, continuous improvement drives our people toward constant innovation, working together around the world to solve life's challenges. Just people helping people. Not simply to take groundbreaking products to market or license advanced technologies for the benefit of others, but to make family time more fulfilling, free time more exciting, and bedtime a little more cozy. We're in your cars, your carpets, even the fiber in your clothes, because we're in the ingredients that make it all possible, and so much more. We're in a lot of the things you care about, and in a lot of the things that take care of you. But ultimately, we're invested in making the world around you a better place. To work in, to live in, and to thrive in. Are you in?
Awesome. Well, so now that you guys kind of know a little bit about Envista and have an introduction to us, I want to talk about why digital twins are important to us and how they help achieve the vision that you just saw. So as a manufacturing company, we have a lot of people who are doing a lot of different jobs and have different skill sets. And so there's a couple challenges that we face when we want to connect the workers who are out in the field to the data that can actually enable them to make decisions faster. And one of those is that our assets or our data assets are in silos, right? And so much like many of you guys probably, there's 4 or 5 different platforms that people might use. One's for accessing work order instructions, another's for accessing IoT data, another might be for accessing a 3D model or piping and instrumentation diagrams, all these different things. And so people, to Sarah's point earlier, are context switching back and forth. So they're trying to understand, if I'm looking at this on this diagram and then I look at the data, is what I'm seeing in the diagram coming from the same place that my data is at, that I'm looking at in this other database. So we have a real challenge there. And to the kind of resolution point, the goal, especially in chemical manufacturing, we want people to be able to make really good decisions the first time. A lot of times, people have to make critical decisions, and we want to make sure they have the best data to enable that decision-making process. And then from the context of an overall plant, a lot of times we're limited to whatever the job role is. I'm going to take this off. We're limited to whatever the job role is that we're focused on at the time that we're working on it. And so, for instance, if I need to get an understanding of kind of a cohesive image of an entire facility, it's really hard for me to do that if I'm looking at a dashboard that only covers motors, right? And so the context is really important because, particularly in process type manufacturing facilities, everything's interlinked, right? So if there's an issue down here, more than likely you might have an issue downstream, and so all these things affect each other. So seeing this kind of cohesive whole and getting an understanding of that is really important. So I'm going to kind of walk through an example of where somebody would use something like TwinMaker. So let's say I'm an operator out in the field. I'm doing my routine walkthrough for the day, and you might see like an oil fill that's low. The challenge is I don't know when the last time the oil was changed. I don't know if there's a crack or if it's just that it needs maintenance. There's a lot of things that I don't know about the situation that's going on. And if you use the kind of analog version, or what we've done traditionally in the past is we've had to go back to our desk, sit down, open the software that we use, find the piece of equipment that I'm looking for, type it all up, submit it, go back out in the field, find more information, potentially fix it or not. So there's a lot of steps involved there. And what the digital twin stuff allows us to do is we can now essentially serve that up to the person at the time that they are looking at the asset that they're going to be working on, and they can actually submit data from the field as well. So the new solution to this would be, I walk out, I see that the oil level's low. From my phone, I pull up Grafana or TwinMaker. I put in a SAP work order that says, hey, this is what I need. I check the work order history, and I say, okay, I recognize that it's probably not a leak because the oil hasn't been changed in a while. And then everything that I need is right there in front of me. I don't have to walk back to a desk. I don't have to go and ask somebody for SAP access. I don't have to do any of that stuff. And so it's really valuable to have this kind of abstraction layer where you can aggregate a lot of the data together in one piece. And then the other thing that we're trying to address with the digital twins is, and I'm sure you guys may be experiencing this as well, we're losing talent both in the form of retirement, and these folks are masters of their craft, right? They have a lot of experience, and so how do you institutionalize that experience so that people can learn from that and be as effective? And I have a funny story that I love telling around this. One time I went to a facility, and there was a guy, and I won't name his name, but he had been there for like 40 years, obviously was one of the most senior people there, like knew the plant like the back of his hand. And so I went on a round with him, and I'm following him around, and we stop in this area, and he kind of stops and like moves his head. And I'm like, what's going on here? We're standing in the middle of a chemical plant. And he says, well, something sounds off. I'm like, we have earplugs in, man. Like, I don't know what you're talking about. And he goes, no, something sounds off. I was like, okay. So what's going on? And he like walks over, and he's feeling the pumps, and one's apparently vibrating differently. I can't tell the difference, but he knew that one was vibrating differently. And he pulls a screwdriver out of his pocket, sticks it on the motor, and puts his ear to it. And he goes, yep, race bearing. And I'm like, okay, clearly you know something that I don't, right? And so that's a good example of, these are experiences that, he's the original connected worker, right? His connection just happens to be that he spent 40 years and knows it really well. So what we're trying for is, how do you create a tool that augments people's experience so that they can kind of understand the same context as what that operator did when they put the screwdriver to a motor to hear for a race bearing? How do you actually provide that context through data and a visualization so that it doesn't take 40 years for people to be able to understand what they're looking at? So as we kind of recognized, we said, hey, we know that we need to address this, and we know that we need tools that help us do this more effectively. We started scoping out if we wanted to build something like this ourselves, what would this take? And we recognized that as a manufacturing facility, we don't have the technical resources to throw 50 people at starting up a platform to be able to support this across the business. And so we were thrilled when Saris and the team at AWS reached out to us and said, hey, our goal is to create this aggregation layer where we can actually overlay data on top of a 3D model. And so they've been a great partner for us, working through how does this actually get implemented in an industrial company. Sorry. So effectively, what we worked with them on are these three things. So we need to connect the dots between data sets. As Sarah's mentioned, it's important too that we don't have to aggregate them all into one database. Like, we want to be able to access the data where it lies, because we have it all over the place, right? And who knows what kind of relationships can be drawn between different pieces of data, and so having that be accessible is really important. We want to build a contextualization platform. So we want 3D models. We want people to be able to look at the models and understand, okay, when when there's a race bearing going out and something's flashing, I can look at the motor that it's actually going out on, and then I can understand, okay, based on where it's at, I might need a tool cart, I might need XYZ tool, et cetera. And so there's a lot of context that can be provided by having a 3D asset in front of you to look at. And then the last thing that's really important to us as a company is this concept of citizen developers. So what we recognize is that if every dashboard and digital twin relies on Dane to set up for people, we're going to be here for the next 20 years waiting on Dane to be done, right? And so what we needed is we need something that's easy enough and accessible for people who are interested in the space to jump in and be able to make the interactions or be capable of creating the partnerships or relationships between the model and the data that we're talking about. So a big key thing here, or a key message here is not that we're looking to displace people with digital twins. What we recognize is that digital twins allow us to essentially focus people on what they do best and get rid of a lot of the kind of context switching, cognitive friction, all these different things that people deal with on a day-to-day basis. So here's an example of our actual facility in TwinMaker. And there's kind of four key pillars, if you will, that attach here. And one caveat here too, you'll see when we jump in, there's a kind of like a live view, or I shouldn't say live because it's not live, but it's a high definition perspective. And then this is actually the CAD model or a GLB model, if you will. And so the thing that enables this is, from an asset information perspective, we use OSI Pi. OSI Pi allows us to aggregate data from a lot of IoT sensors into a place where we can put it on dashboards and actually deliver it to people. And so we're pulling from OSI Pi here. You can see on the right-hand side there's live data coming in from the field. And then we're using Snowflake as well as essentially a data warehouse to make it easy for transmission and that kind of thing. And then you have TwinMaker who comes in and they allow us to do alerts. So we can use DCS alerts, or you can use control room. You can customize your own, and you can build rules around this. So in this situation where it turned red, it was because it was out of spec for a rule that I set for that piece of equipment in my dashboard. And then the final piece of this is Matterport. One of the biggest challenges in the digital twin space is being able to create 3D models that are actually portable and accessible for people. So if you think about a point cloud, that was one of the first places we started, is we generated all these point clouds, and it's really cool because you got like 1 trillion dots, right? And it's real exciting. The problem with that is it might be a terabyte in size, and nobody's going to download that on their iPhone and use it in the field. Right? And so we needed a lightweight solution that allowed us to give people the context that they need, but also not destroy the bandwidth of the site because we're downloading models all the time. And so this is where Matterport comes in, and they've been also a great partner for us, and we're really excited about the collaboration that's happening here. So for you guys that may not know, this is a video of Matterport and all the different kind of modalities you have. And so this is the kind of pretty perspective. As you can see, this is our actual facility. It's in high resolution. And what we've done and what we've used Matterport for to this point is we can label things. So when you're teaching people about a piece of equipment, you can actually show them what you're looking for. You can create links and do that kind of stuff. The thing that TwinMaker kind of enables over the top of this is that you also have a data layer, right? So you have the context as far as descriptors, you can add links, and then now I can pull in IoT data, SAP information, all these things. So this is kind of a rough version, and I'm calling it out because I know it's rough. But the end product will actually be the view that you saw of Matterport that's high definition, completely integrated over the top. So we're super excited about that because what that means is that everybody that's out on the shop floor will have access to high quality models. And so, I mean, you can count the, or you can read tags and stuff on the labels, which is really, like I said, high fidelity. And it actually will load at a reasonable pace. It's not super burdensome. And so the integration between TwinMaker and Matterport is huge for us because it allows for that kind of synergy between the two platforms. So the business outcomes that we're looking for, like I said, knowing the context or knowing the location of the different assets that you have around you improves productivity for field operators. So, if they get a work order and it comes through on their phone, on their email, and they have a link that says, you have a work order that's here, I click on it, it takes me to the location of the piece of equipment that I'm supposed to be doing work. I zoom out and I go, okay, it's that motor, it's not one of the other 12 motors that are in that bay. Right? So that context provided me the understanding of where I'm at, where I need to go, and all these different things. And so that's the context that we're talking about. And one of the things that we're most excited about is we think that really enables people, especially if you're, are walking around and have to cover a large area. It allows you to kind of really get a good understanding of your environment. We want to continue to build excellence in environmental health and safety. We want to make sure that people are safe, and if we can provide additional contextualized information that help them make good decisions when they're out in the field, that's a really valuable thing for us, and we're really proud of our EHS record. And we want to make sure that we're leveraging human expertise to create value for our employees. So we think that there's a lot, there are tasks that are burdensome for people, and we'd much prefer to offload that to a platform and allow them, again, to do what they do best and do what they're passionate about because passionate people do really impressive things. And so what's next for us? Well, the first one's scale, right? So again, with Matterport and others, we can ship cameras to facilities that have never had 3D models before, and people Bluetooth connect to their device, walk around, scan the facility, upload it, and then we make the connection with TwinMaker. So that's our goal, is to continue to scale out. We have facilities that are scanned, we have facilities that are scheduled to be scanned, and so that's kind of the next step. We want to foster that citizen developer capability, so we want people to look at it and imagine what their lives could be and how things could be transformed if they only could use a 3D model, and then we want to help them build it, and then we want to empower them to build it for themselves and to share with others. What we recognize in this space is that any group that you talk to, so if you talk to an operator versus a maintenance technician versus somebody in supply chain, they're all going to give you different answers as to what digital twins are good for, which is great because that means that we have a lot of opportunity. It means that there's a lot of value to be had. The challenge is that I can't build it for everybody, right? And I don't know everybody's job to the degree that I need to in order to effectively build that. And so that's the next capability that we want to build is, hey, how do we help enable you to build something that's valuable? And then can we share that with people in similar type of roles? Finally, we want to make sure that we continue to collaborate with the AWS team. Like I said, the AWS team's been great as far as kind of listening to feedback from us and implementing it. And we hope that that collaboration continues throughout the industry too, not just between the two companies here. So with that said, I do want to say thank you for you guys for being here and listening to us. I want to say thank you to the AWS team again, and also thank you to the internal Envista team that made this possible. I really appreciate it. At this point, I'll hand it back over to Saris, and she can finish it out for us.
Thank you, Dane. And thank you, everybody, for coming. I hope this was entertaining, helpful, not boring, at least. So, as I said, visit us at the booth. I want to plug a Chalk Talk that's happening on Friday. It's IoT 317. If you're interested in learning and getting a more hands-on information on the technical details of the service and how you go about building digital twins, please be sure to check that out. Again, it's IoT 317. And please remember to fill out the session survey. Thank you all for coming. We'll be here. We have 10 minutes for this room, so we'll be here in case anybody wants to come up and ask us questions. Happy to chat. Otherwise, thanks for coming, and I hope you have a good evening.